So we are going to go through the SAC, and I'll first start off with day one. So for day one, it was really getting you to focus on understanding linear, understanding parabolas, and understanding in terms of a context of a park. So the first part, it says, I'm just going to click on draw. Okay. It first says we are doing a linear pathway that crosses the park. So straight away, first thing I'm going to think about is if I draw my park, I'm having a linear line going through my park. This line we know is going to be 150 meters. So that part there is going to help us for I and II. So it says write the equation for a pathway that spans 150 meters diagonally, passes through 0, 0, and has a gradient of m, where you can choose and justify an appropriate value for m. So a lot of people, I noticed, did a simple equation y equals 2x. The reason why they picked that is because they knew that that they wanted both of these sides to be identical, which means it was going to, of course, be a square. So you could have done it that way. You could have picked a value, and I could have gone, okay, I am wanting 45 degrees or 30 degrees. So I could have put 30 degrees in here. 30 degrees will be my gradient, and I would have been found that out and put that in front of my x value there. I could have used that then to work out my domain and my range by using my basic understanding of trig. So to find the adjacent, I would have done is cosine. Cosine 30 degrees is adjacent over 150 meters. And to find my range, I would have done sine 30 degrees is equal to opposite over 150. But I'm just going to keep it simple. We know we've got y equals to x. I want to be able to justify my m. By justifying, I'm stating that I want my park to be as rectangle, to be a square to maximize the area. To work out the domain and range of this, I'm going to use Pythagoras theorem. So a squared plus b squared is equal to 150. I know that my domain and range when my is this going to be the same, so I can rewrite this and say 2a squared is equal to 150. 150 squared, and then I can simplify this down. I'll divide everything by 2, and I've got 150 squared over 2, and then I will square root. I square root that will give me 150 over square root 2. I can go one step further and rationalize this by timesing both by square root 2, and that will then give me 150 square root 2 over 2, which then gives me a is equal to 75 square root 2. So then my equation is going to be y equals to x, and my domain is going to be for when x is equal to or greater than 0 and equal to and less than 75 square root 2. Now, one of the things we need to be thinking about, we're talking about measurement, we're talking about length. So that means we are staying in the positive area. So a lot of the mistakes I saw were people were going into the negative area. So that part there was worth 2 marks. The next part is our domain and range. So my elements, again, you got full marks if you wrote it with this notation. So the domain elements are going to be equal to 0 all the way up to 75 square root 2. And the range elements are going to be 0, comma 75 square root 2 using the appropriate brackets. Some people lost a mark because they went into the negative area with the domain and range. Now, this is probably the easiest one to graph. We can use the Cartesian plane and use a graphing our SAC calculator, but we can just put it on. Now, when I'm doing this, I'm going to look at what is my value. So we know 75 square root 2 is 106. So we need to be thinking about what we are going up by. So I'm going to be going up by is 25. 25, 50, 75, 100, 125, and then up here I've got is 25, 50, 75, 100, and it goes a bit higher. So some people lost marks because they did not label. And another thing is some people didn't put their points accurately on here. So be mindful of that. Now, our first graph, we know it when x is 25, y is 25. So this is why this one's a lot easier for us to graph. Now, what I'm going to do is I'm just making sure that I am only showing the domain of what I'm wanting. Some people went down here and lost marks. So some people went down into this negative area, which we don't want to see. Let's rub that part out. Okay. So the next thing is we need to always have our starting point, so our endpoints on here. So that means, so the starting point here was 0 and 0. Oops, I need to change that. Okay, blue. And I'm just going to double check, oops, what our other one was. So I'm just going to go up. Okay, so I just wanted to double check that it is, the max is 75 square root 2. So I'm just going to go back down now and I'm just going to write that in. 75 square root 2, 75 square root 2. That will be my endpoint. That's like 106. So those are the 2 points that we need. That's been slightly moved. Okay, so now we are going to go down and look at the next. So this here is, it says there is a pond that has the equation y equals negative a half, x minus 20 in brackets to the power of 2 plus 70. So again, we are just going to look at where is the turning point, because it's wanting us to graph. So the turning point is just going to be when x is 20, y is what's over here is 70. That's the next thing. Now I'm going to look for my x-intercepts. Now this is, we're able to use it's ClassPad for this. That's what we are going to do. So if you type it in and graph it and go to interactive and roots, you'll be able to find the x-intercepts that are 8.16 and 31.83. That is the information that we need. So if I go back up here, I first put my turning point. So this is 25. So we can see if I go 5, 10, 15, 20, it's not quite 5 for every single box. So be mindful of that. So we're just going to be approximating at the moment. So we're dividing this area by 5. So it'll be just in the third box here. So when x is 20, y is 70. So it's going to go up and it's going to go approximately here. I'm just going to label that. Now, some people had it here, but they had it up above here, above that 75 line. So be mindful of where you're placing it. It needs to be accurate. Likewise, we know our intercepts are going to be at 8.1 and 31.8. So it's approximating. So it's about here. Again, because it's an intercept, you must label it. So I know we got 0, 0 there, but if you can do it slightly down, 8.16, comma 0, and then the second point was 31.8. So again, it's approximating where it is and making sure that you are labeling that as well. So 31.832. Now from there, we are able to graph it. So some people decided to take their graph into the negatives. Again, be mindful that we don't need that. Okay, so now we've got our graph. Let's go to the next part. State the domain and range. So normally if we look at a parabola, we always say that our range here it's going to go all the way down into the negatives, and our domain is implied is all real numbers. But we need to take into consideration what we are allowed in this circumstance. So let's look at range first. The lowest point we can get for range is 0, because that's the x of the park. We're going all the way up to 70. So we've got 0 to 70. Where's my domain? Again, if I go here, is between these two x values, because those are the widest points of our lake in the park. So again, I can just write that down. So domain elements are 8.16, comma 231.8. Again, inclusive. Now, this is the part we need to work out, is the length of the bricks required that's going over. So we can see here that that there's one intercept and there is a second intercept. You will need to label that. So again, when we're thinking about where they are intercepting, we need to be mindful that all we're doing is putting it into the calculator and finding the intercepts using an understanding of simultaneous equations. So that's all we're going to be doing. So if I've done that, then I straight away, it's going to come up with the answer of 8.95 and 8.95. That is the first point that it's crossing. The second point is it's going to be 29.04 and 29.04. So if I go back to this, you need to make sure that you have labeled that on here. 29.049, or I'll just put 05 and 29.05. And my other one was 8.95, 8.95. So we've got all of our points there. Okay, let's continue. Now it says we are working out the length of the line segment. So we've got our x1 and y1 and x2 and y2. So if we think about the rule for a length of a line segment, the length is going to be the square root. We're using our understanding of Pythagoras. x2 take away x1 squared plus y2 take away y1 squared. So all we're doing is putting this information into this formula and then solving it. Now I'm going to do a couple steps at the same time. of course, we can use our calculator. So I'm just going to go to 29.04, take away 8.95. And then I'm going to square it. And that gives me 403.6081. Now, we've got double of that. So I'm just going to times that by 2. It's much easier than having to worry about everything else. Okay, so if I times that by 2, I'm going to have my distance is equal to 807.2162. And I just need to square root that. And you're going to get 28.411411. Or if you did more of decimals, you'll get closer to 28.42. So that's the length. Okay, let's move on to C. So now we're just wanting to be able to sketch a circle. So this circle is what we are going to use. Again, this part here is my radius, but if we think about it as radius, we need to think about it as squared. So the radius would actually be the square root of 2. So be mindful of that. This part here tells me my origin. So my origin is going to be when x is 20, y is 40. Because it's asking us to sketch, we need to have this information. Now we go up. So I'll zoom in. Okay. So when x is 20, y is 40. So it's going here, we've got 25, 30, 35, 40, 45. So it's going to be about here. I want to make sure that our origin is labeled. So our origin was 2040. So I'll label that as 2040. Now, if our radius is square root 2. So square root 2 is actually a very small number of 1.4. So it's a very small circle that we are doing. So that's really all we had to do. Okay, let's continue. This is the last part that we had to do. Construct a piecewise function to represent the updated pathway, including a detour via the islet. Okay, so detour. That's the hardest part that people struggle with. Now, I didn't tell you what you had to pick in terms of types of graph. So you could have just stuck with linear for this. Now, first, we need to look at this first part. So this first part here is we are going to just deal with that. So we're going to have 4 equations. 2 is what we know. So I'm going to write the 2 we do know. The first equation is y is equal to x. And that is for the domain starting at 0. And I'll go back up. And it goes all the way to that intersection point of 8.95. The fourth equation that we already have is the same one, y is equal to x. And again, I will go back. And that is starting at this intersection here of 29.05. And is continuing. Now, this continues up until the end of my domain, which is 75 square root 2. Okay, so we've got our first 2 parts. Graph 2. We know it needs to go through 8.95 and 8.95. It also needs to go through the mini island, so which is at 20 and 40. So I'm just going to put 20 and 40. Now, the easiest one we can do is a linear relationship. So I'm just going to do linear for this. I'll first find my gradient, which is y2 minus y1 over x2 minus x1. So that means I've got 40 take away 8.95. And that gives me 31.05. And then I've got 20 take away 8.95. And that gives me 11.05. I am going to simplify that and go 11.05, sorry, 31.05 divided by 11.05. And that will give me 2.8099. Now, if we use our understanding of coming up with a linear equation, we can just substitute everything we know in to find C, or I can use a lovely formula that comes from the gradient of y take away y1 is equal to m x minus x1. I will just plug in all the information I know. I'm just going to use the easiest one of 20 and 40. So I'll go y take away 40 and m is 2.8. So 2.8099 x take away is 20. Okay. Now, from that, the last thing I'm going to do here is I'm just going to get 40 by its to the other side. So I get y by itself, and I'm going to expand. So that means I'll get 2.8099 times x. And then I'm going to get 2.8099 times negative, it's 20. And then I'm going to add 40. And that gives me negative 16.198. So then we're going to just write down the domain of this second equation. So our domain is going to start off, so domain is going to start off where our first equation finished, so that is 8.95, and it's going to continue all the way till we get to our mini island at 20. That's the second equation. The third equation. We've got our 2 points. We know it's going to go through 20 and 40, and if we go up, we've got a second intersection point at 29 and 0.5. So just doing exactly the same thing. 29, 0.5, 29, 0, and 5. So, same thing is going to occur here. So I'm not going to do all the steps for this. I'm just going to leave it. And I'm just going to show you how we write it as a piecewise. So for the piecewise, we've got, well, I haven't yet, but we've got our equation. So we've got the first one, which is equal to x. We've got the second equation, which is 2.8099x take away 16.198. We've got a third one, I'll leave a dotted line for, and the fourth one is again just going to be x. On the right-hand side, and some people made a mistake of putting the domain first, on the right-hand side, that is where we put our domain for each of our parts. So for the x1, it is x is equal to and greater than 0, and equal to and less than 8.95. So I straight up a space there. Then I go to the next one, and that is starting when x is going to be greater than 8.9, and it will be equal to or less than, it's 20. I'll do the next one and the next one. So I'm just putting my domain down the side there. And of course, I end it with the brackets.